this statement or blocks of code are placed for expansion. Every if def limit statement will be evaluated to false. The output of this is inside function 1, inside main 1, then inside function 2 is going to be displayed. I just want to pass on the arguments from calling function to the called function. Hello everyone, it is Dr. Ravi Kumar YB. In today's session, we shall learn about the macro preprocessing with conditional compilation. What is the meaning of conditional compilation? As you have already seen that the conditional compilation is one that does the task of execution of statements included within the conditional statements based on the satisfactory information included in the conditional statement. That is, if I write down any if conditional statement, if the condition is satisfied, the statements included within the if is executed. Otherwise, it skips the execution of the statements included within if. If in the same manner, we have conditional macro statements, that is the statements which are included within the conditional form are going to be skipped or executed based upon the conditions. Let me take you into the details of it. The conditional compilation directives are type of directives which helps to compile a specific portion of the program or to skip compilation of some specific part of the program based on some conditions. That is what I explained right now. That is based upon the conditions which you have incorporated in your program, the statements are going to be executed or going to be skipped. That is how the conditions are going to be validated. That is, this can be done with the help of two preprocessing commands like if def and Ndef. If the definition with macro name. What is that macro name? Let me have limit with some conditions. Let me have some conditions like less than or greater than. Then it has to be end with and if. Any statements that is included within this macro limit is going to be skipped if the condition fails here. If the condition is satisfied, then the statements are executed. That means this statement or blocks of code are placed for expansion before the actual compilation. That is how it is going to be done. If that is the case, let us see to it. If definition, macro name, that is limit. Within that we have a set of statements here. Statement 1, statement 2, statement 3, so on up to statement n. These set of statements are going to be replaced or placed into the location of limit if it is required, if the condition is satisfied. Otherwise, these statements are not at all placed in the place of macro name for the purpose of skipping it. If the macro with the name as macro name is defined, then the block of statements will execute normally. But if it is not defined, the compiler will simply skip the block of statements. That is, placing this entire piece of code is not going to be placed in the place of macro instruction. Then we shall see that there are other directives. Apart from this include directives, macro directives, conditional directives, there are other type of directives, that is other directives. In this other directives, you will see that Ndef directive. What is the purpose of using this Ndef directives? Let me take you into that. If there is any functionality or any macro defined in your program is not required at the later point of time, then you can use the directive called #undef. that will exclude the functionality of that macro from your program. Similarly, let me take the functionality that is limit. Limit is the macro name that is not going to be used after some point of time. Then I will use #UNDEF limit. Using this statement will undefine the existing macro limit. After this statement, every #if def limit statement will be evaluated to false. That means anything which is included within this, or any 5 is included, or 10 is included, or anything, if you include any of this directive with this #UNDEF, that excludes the limit macro from the program. That is how it is going to be done. Then we shall look into the other type of directives. We have Pragma Directives. Pragma Directives. What is the use of this Pragma Directive? This is a special purpose directive which is used to turn on or turn off some features. At some point of time, you want to make use of the functionalities of macros in your program. At later point of time, you do not want to make use of those functionalities in your program. Then you can use this Pragma Directives. Then how does the Pragma Directive works? Let me take you into that. Pragma Startup and Pragma Exit. Pragma Startup will indicate that it is turn on. We are going to use the functionality of that. Pragma Exit indicates that we do not want to use that functionality of macro in our program. Suppose if I want to use the functionality of some macro limit in my program, I can do so by using this startup directive, and if it is not required, I will use the exit directive that makes the system exclusion of limit macro from my program. So this is how we are going to use it. Let me take you into the examples of this. See here, #include, we have one of the include directive. Then using namespace std, that is for performing the standard operations. We have a function called func1, function called func2. Then we have a start #pragma startup function1, #pragma exit function2. If you look at this, you will clearly understand that when the function 1 is started, function 2 must be exit. When the function 2 starts, I do not want to use the function 1. Later, I will make use of that with exit. So I can use either startup or exit operators here to make use of the turn on and turn off features of the other directives, other types of directives, that is the Pragma directives. Similarly, we are inside this function 1, we are inside this function 2. Now, let me take you into this. We are inside this main function. The output of this is inside function 1, inside main 1. Then inside function 2 is going to be displayed. Because I am using the #pragma exit func2, that is function 2, there in my program. This will turn off the execution of this function 2. This function, this statement will not be executed at all. That is, of course, there is a function call, but when this directive is encountered, this is a pre-processing directive. Before the actual compilation begins, this is going to be pre-processed. So it states that function 2 is not at all required with exit statement. So the function 2, that is the function 2 is not going to be invoked at the beginning. Only the function 1 is invoked. At later point of time, I will make use of this function 2 with startup function again. Then it is invoked. That is, we are going to use the functionality of that whenever it is required, and we are going to exclude the functionalities of macro using the #pragma directive when it is not required. So if that is the case, let us see to it in case of this. It will produce the output given below when run on GCC compiler. Inside the main function, let us see to it. Because GCC does not support #pragma startup or exit. However, you can use the below code for a similar output on GCC compilers. This does not support the GCC, does not support the Pragma directives. If you want to make use of this, Turbo C compiler will support that. Borland Corporation will support that. Will support the Pragma directive. But which is that environment that does not support the Pragma directive? GCC is the environment that does not support the Pragma directive. Next, we have the functionality that is void function 1 here, void function 2. These are the two function calls here. Now I have one of the attribute with constructor and function 1 and another one for destruction and function 2. We have these attributes here. Let me take you into the details of that. Now we are inside the function 1 and we are inside the function 2. That is the statement going to be executed when this particular function definition is invoked. When this particular definition function 1 is invoked, this statement is executed. When this function definition is invoked, this statement is executed. But see to it, inside the main function we have this. Next, we have Pragma Directive. Before I move on to the Pragma Directive, let me show you that this constructor with attribute void double underscore attribute double underscore. This is the inbuilt functionality that indicates that function 1 must be used as a constructor and function 2 must be used as a destructor. Then what is to be defined inside this function 1? Within this, if you want to initialize any of the variables, you can do so using the initialization, that is int a is equal to 10, int b is equal to 20. You can do so all these things within a function 1. But within a function 2, you need to free up the space of this allocated to these int a and int b. If that is the case, you can use delete operator. Delete a comma b. This deletes or destructs the memory locations which are assigned to the variables a and b. That is the destructor. It is working as a destructor. So there is also a possibility called warn directive. Suppose if there is any mistake in a program that is going to affect the execution of a program, it can warn you that this is the mistake that is going to happen in the program, so that the compilation of a program begins smoothly, which are displayed during the compilation. We can hide the warnings as well using these options -rvl, rch, that is RCH and -PAR. These are the different types of warnings that we can give it to the system. If that is the case, which is the first type of warning, this directive hides those warnings which are raised when a function is supposed to return a value, does not return a value. If you look at this, observing that the value 0 is to be returned to the main function. If that is the case, if there is nothing to return, what happens? Obviously, it generates an error. I do not want to generate an error. I just want to warn the system that this is the mistake committed by the programmer, so that the programmer can check and verify that the mistake and clear the mistake which is done at the point of returning statement using the Pragma warn directive. Pragma warn directive with this option -rvl return value RVL. Similarly, RCH we have that #par. This directive hides those warnings which are raised when a function does not use the parameters passed to it. Suppose I have certain functions or arguments, functions with arguments. I just want to pass on the arguments from calling function to the called function so that the functionality of that works smoothly. In that case, the parameters which I have passed from the calling function to the called function may be used or may not be used. In case if it is not used, then the warning must be raised. That is called as this. Using the #pragma warn-par hides the warning which can be generated to the programmer. Similarly, #pragma warn-rch, that is, the code is unreachable. That is, suppose if there is any code which is not reachable during the time of execution, then you can do so. That is, you can hide the warnings which are going to be generated for the code which is not reachable. You can hide those things by using the functionality called #pragma warn-rch. This is how we are going to do the operations, that is the preprocessor directives. Dear students, you people have come across the different types of preprocessor directives. That is, the first one is macro preprocessor directives, second one is include directives, that is, then third you have come across the conditional compilation directives, and the fourth, finally, we have come across the other type of directives which includes Pragma kind of directives. If you have come across any questions with respect to the topics I discussed today, kindly come back to me during the live sessions so that I can clear all of your doubts. Thank you very much. Thank you one and all.